Hello viewers, welcome back to our YouTube channel Incredible Maths. In this video, we will solve some problems asked in GATE 2022. So the first problem, this problem is related to the assignment problem. Let us see. Three companies C1, C2 and C3 submit bids for three jobs J1, J2, J3. The cost involved per unit are given in the table below. So there are three companies and three jobs, so we have to allocate the jobs to these three companies, and the problem is to find the cost of the optimal assignment. Okay. So here we will see the first row, so 10, 12, 18, so 8 is the minimum, so we will assign the C1, that is J3 job number 3 to company 1. So this can be assigned, and in let us see for J2 and J1. So J1 can be assigned to C2. So in this row, this is the minimum. So now we have to allocate the job J2 to the company C3. So already for company C1 and C2 jobs are allocated. So the only company which is left is C3. So we will allocate this one J2 to company C3. So three jobs are allocated to three companies. So now we will find the optimal cost. So here the cost is 8, and here the cost is 9, and here the cost is 10. So therefore the answer is 8 plus 9, 17 plus 10, 27. So this is the answer. So this is done based on the row minimum concept. So let us see the other problems. So this problem is also related to the optimization techniques or operation research. So here we need to find the optimum value for the linear programming problem. So the maximization problem subject to the two constraints x1 and x2, where x and x2 are greater than or equal to 0, x and x2 satisfy these two conditions. So first we will draw the graph for this. So first we will find the coordinates correspond to the coordinate points corresponding to the first constraint, 3x1 plus 2x2, 3x1 plus 2x2 equal to 12. So when x1 equal to 0, so we will get x2 equal to 6, and when x2 equal to 0, so we will get x3 equal to, so put x2 equal to 0 here, we will get 3x1 equal to 12, so x1 equal to 4. So therefore the corresponding points are 0, 6 and 4, 0. So we will mark these two. So we will similarly we will find the points corresponding to the second constraint. So second constraint is minus x1 plus x2 equal to 1. So when x1 equal to 0, we will get x2 equal to 1, and when x2 equal to 0, we will get x1 equal to minus 1. So therefore the points are 0, 1, and here it is minus 1, 0. So we will draw the lines. So this line represents 3x1 plus 2x2 is less than or equal to 12. So this is our x1 axis and this is our x2 axis. So we will find the region. So to find the region, so take a reference point. So here we will take a reference point as 0, 0. So we will substitute this point in this constraint. So suppose if this constraint satisfies, then the region will be the one which contains the point 0, 0. So let us substitute 0, 0 here. So you get 0 plus 0 less than or equal to 12. Therefore the condition is satisfied. So our region contains this reference point. Therefore So this is our region. So let us take some other color. So this is our region. So since x1, x2 are greater than or equal to 0, so this is our region. So next we will mark the second constraint. So the points are so 0, 1. So 0, 1. So will be here. So this point is 0, 6, and this one is it is 4, 0. So we have 2 points here, 0, 1. So 0, 1 will be on the y axis. So this is 0, 1, and this one is minus 1, 0. So let us draw the line here. So this line represents minus x1 plus x2 less than or equal to 1. So this one line. So now we will find the region. So for this also we will take 0, 0 as a reference point. So when we substitute 0, 0, we get 0 less than or equal to 1. So therefore this is satisfied. So the region is below this line. So therefore so this is the region. So the common region is this one. So this is our common region. So the common region is, so this is our common region. So therefore this is our region. So now we have to find this intersecting point. To find the intersecting point, we have to solve 3x1 plus 2x2 equal to 12, and second equation minus x1 plus x2 equal to 2. So x2 equal to 1. So multiply this equation by 2, we will get 2x minus 2x1 plus 2x2 equal to 2. So solving this, we will get 5x1 equal to 10. So this implies x1 equal to 2. So we have to find x2. So we will substitute in minus x1 plus x2 equal to 1. So x1 is 2. So minus 2 plus x2 equal to 1. So therefore x2 equal to 3. So this point is 2, 3. So now we will find the z corresponding to these points, to these corner points. So points and z. So what is the z equation? Z is 6x1 plus 5x2. So when z is point is 0, 0, so z is 0, and you will take 0, 1. So in 0, 1, z is 0, 1, it is 5, and z is 2, 3. The point is 2, the corner point is 2, 3. Z is 6 into 2 plus 5 into 3. So 12 plus 15, it is 27, and another point, corner point is this one. So 4, 0, is 24. So 6 into 4. So therefore, so from this, so our problem is a maximization problem. So therefore we have to find a maximum z. So the maximum z is 27. So therefore the answer is 27. So the optimum value for the linear programming problem is 27. So we move on to the next problem. So this problem is also related to the operation research. So certain product is manufactured by plants P1, P2 and P3 whose capacities are 15, 25 and 10 units respectively. The product is shipped to markets M1, M2, M3, M4 whose requirements are 10, 10, 10, 20 respectively. So it's a transportation problem. So we have to find the basic solution using northwest corner rule. So first we will check whether the problem is balanced or not. So we will find total the row and column. So 10, 20, 30, 50 row total and column total 15, 25, 30, 40 and 50. So the problem is balanced. So we can find the solution. So we can find the solution using northwest corner rule. It is already given. So that means from the northwest cell, so corner cell we will be allocating the cost. So here 10, 15. So therefore we can allocate 10 here. So so 10 minus 10 is 0. So here 15 minus 10 will be 5. So for this row, for this column we cannot allocate. So therefore we will cancel this column. So next we will allocate to this cell. So the minimum of 5 and 10 is 5. So therefore we can allocate 5. 5 minus 5 is 0. So therefore we can cancel this row. And 10 minus 5 is 5. So now we can allocate the minimum of 5 and 25. So that is 5 we can allocate here. So 5 minus 5 is 0. So we can cancel this column. And here 25 minus 5 is 20. So the minimum of 10 and 20 is 10. So therefore we can allocate 10 here. So 10 minus 10 is 0. So this column is cancelled out. And 20 minus 10 is 10. So now we have 20 and 10. So minimum is 10. So we can allocate 10 here. So 10 minus 10 is 0. And 20 minus 10 is 10. So now we can allocate 10 here. So because we have both 10 here. So minimum of 10 comma 10 is 10. So 10 minus 10 is 0. And here also 10 minus 10 is 0. So the allocation is done. So we will find the cost. So for 1 unit it is 10 rupees. Therefore 10 into 1 plus 5 into 3 plus, so here it is 5 into 2 plus 10 into 4 plus 10 into 1 plus 10 into 2. 1, 2, 3, 4, 5, 6. There are 6 allocations. 1, 2, 3, 4, 5, 6. So we find the total. So 10 plus 15 plus 10 plus 40 plus 10 plus 20. So the answer will be 10, 20, 25, 35, 35, 75, 85 and it is 105. So the answer is 105. So you see one more problem. So this problem is based on linear algebra. So M be a 3 by 3 real matrix such that M square equal to 2M plus 3I. So if the determinant of M is minus 9, then we have to find the trace of M. So M is a 3 by 3 real matrix. Therefore, the degree of its characteristic polynomial will be 3. So we will solve this equation. So since M satisfies this one, M square minus 2M minus 3I equal to 0. So we will write the corresponding terms of lambda. Lambda square minus 2 lambda minus 3 equal to 0. So this can be factored out as lambda minus 3 into lambda plus 1 equal to 0. So the lambda is equal to 3 comma minus 1. So these are the eigenvalues. So we know from this we can see that two eigenvalues lambda and lambda 2 are 3 and minus 1 respectively. So we need to find a third eigenvalue. So to find third eigenvalue, so there is a relation between the product of eigenvalues and determinant. So determinant of a matrix M, so is equal to product of eigenvalues of M. So determinant of M is given as minus 9 product of eigenvalues lambda 1 into lambda 2 into lambda 3. So lambda 1 is 3, lambda 2 is minus 1, so we need to find lambda 3. So from this we can see that lambda 3 equal to 3. So our question is to find trace of m. So trace of m is equal to sum of the eigenvalues. Eigenvalues of m, so that is lambda 1 plus lambda 2 plus lambda 3. So there are 3 eigenvalues, 3 plus of minus 1 plus of 3. So therefore, 3 plus 3, 6, 6 minus 1, 5. So the answer is 5. So if you like the content of this video, kindly like and share with your friends. Also subscribe our channel. Thank you.